Ladies and gentlemen, you are in the right place at the right time. This is Getting Started Python for Digitization, Part 4 of the DT Coding series. We will wait 3 minutes to begin the main presentation in order to give everybody time to settle in and resolve any technical issues they're having. Again, this is Doug Peterson, and we'll begin at 33 after the hour. Quick housekeeping notes. There's a chat window off to the side. Feel free to introduce yourself to your colleagues and friends in the culture heritage community across the globe. And if you are interested while you wait, you can download 3 separate downloads that will be popping up on your screen momentarily. That is sample code that we'll be using today, a link to Visual Studio Code, which you can download that we'll be using to write the code in, and finally this presentation as a PDF. That will help in the case that you want to simultaneously do the coding and look at the presentation, don't want to leave the browser in the front. Again, this is Doug Peterson. You have reached part 4 of the DT Coding series. We will begin at 33 after the hour. Carson, now is the time to please place the sample code, Visual Studio Code link, and presentation PDF pop-ups, and I will say out loud when they're alive. Now, if you are watching this in the future, first of all, very curious how the future is going. Please feel free to reach back in time and let me know. Very curious about some things. Secondly, if you would like to have those links or that stuff that I was just referring to downloading, the pop-ups will only appear in the live webinar, but you can certainly look where the presentation is on YouTube, and there should be in the comments a link to download those items, which Carson will be facilitating after the webinar is concluded. Again, this is Doug Peterson. We will begin at 33 after the hour, which is approximately 1 minute from now. My slide indicates the pop-ups pop up below. That is incorrect. The pop-ups are on the right side under handouts. DT Coding Series Part 4 Python example scripts and images download as a zip, and the DT Coding Series Part 4 presentation. And Carson, if you could pop up the download link to Visual Studio Code. And if you don't want to wait for that link, you can Google Visual Studio Code. I believe the URL is code.visualstudio.com. There's that link. These are optional. If you are either unable to or uninterested in downloading those, you'll still be able to follow along on screen. If you want to do the coding on your own local computer as we go, then you'll want to have those zips and sample code, sorry, the zip of the sample code and the presentation and the Visual Studio Code downloaded. All right, so it is now 33 after the hour, so we're going to begin the presentation. You have reached a DT Coding series in multiple parts. In parts 1, 2, and 3, which you can watch for free on our website, we discussed what coding is, what problems it does and does not solve, and how we as a community can work together to improve workflows using coding. In part 2, we explored how Pixel Digital Transition Service Bureau, is using coding to streamline and automate our post-processing, including barcode scanning, file naming, derivative generation, OCR, and that sort of thing. In part 3, we walk you through step-by-step how to get started with AppleScript. And today in part 4, we'll cover the basics of using Python in a digitization setting. We're going to start at the beginning, from installing the required software all the way through writing short and simple, but genuinely useful tools. In part 5, we'll cover the basics of using the new Capture One SDK. This allows you to leverage the excellent Capture One raw processing math without having to actually open and use Capture One. That opens up a lot of automated workflows and integration possibilities. This class has not had a date scheduled yet because we have been waiting for a major forthcoming update to the Capture One SDK. That is not yet released, and so we have not yet scheduled the class surrounding it, but that is going to be scheduled at that point. Finally, we'll offer a 2-day capstone class that's going to dive in much deeper than the webinars into the topics of AppleScript, Python, and the Capture One SDK. So the same topics as part 3, 4, and 5, but much, much deeper. We've postponed that class from October to 2021. And the reason for that postponement is, again, so that we can include the Capture One SDK update that is forthcoming, because we think that's a really vital and important and valuable part of part 5 of the capstone class. Quick note before we go on to the agenda today, 2 quick notes. First quick note is that the pace and depth of today is intended for beginners. So if you have a lot of previous experience in programming, even if it's not necessarily in Python, you may find the specific pace today to be a bit slow. I just don't want you to get discouraged from attending the capstone class, because that will be substantially faster. That will be substantially deeper and much more suited to somebody who has previous experience. So you can also imagine taking that capstone class, having watched the 5 webinars, and spend some time independently on these topics, getting generally up to speed on them, so that the capstone class will then be very efficacious for you. Last note is that while the 5 online webinars are all free, that the capstone class itself will be a paid class. So that is all that I had to say about the capstone, the DT coding series. Let's move on to introductions. On today, part 4 will be myself and Jeremy. And I am the head of R&D and product management at DT. As of 2020, I'm also a co-owner, and I've been coding since I was 10 years old. I like to say that I've narrowly escaped becoming a programmer as a living when I attended Ohio University for a degree in commercial photography and in visual communications.
My name is Jeremy Moore. I'm the technical manager of Digital Production Lab at the University of Tennessee in Knoxville. I do not come from a background in coding at all, though I've been building computers for quite a while. My degree is actually, I've been a Master of Fine Arts in Photography. About 20 years working in photography and over a decade working in digitization and grant-funded projects.
So I think that's actually a good indication of you as an audience. I expect that many of you do not have a formal degree in computer science, and most people working in digitization do not. Neither Jeremy nor I graduated with a degree in computer science. Neither of us have received anything extensive as far as a formal education, and we're both able to solve real-world problems and save a lot of time using coding. So can you. So let's move on to the agenda for today. It's in 4 parts. Setup, because especially for Python, there's a little bit more involved to get ready to type in some code than there was in our previous class on AppleScript. Next, we'll be talking about, after that, we'll be talking about example code, 2 example problems, basically presented by Jeremy and myself. And then finally, we'll close with next steps, followed by Q&A. So a quick note on the Q&A, if you have questions, please put them in the chat. This is why we do it as a live event and not just a recording that we put out into the world, although it will also be recorded. If you ask the question in the chat, just don't be offended if you don't get an immediate answer. We will likely take breaks, probably at the end of each section, and then we will also have a dedicated Q&A section at the very end. Those questions will be flagged by our moderators, so they're not lost, even if their page is up in the chat log. So feel free to ask them at any time. All right, so let's talk about setup. There are 3 elements to the setup that we need to be concerned with. What language we'll be programming in, specifically which version of Python. Where we will be setting up the environment for Python on our computer, that is, which environment development environment. And then finally, how. How we'll be programming, what will we be typing it into. So let's talk about that first thing, what the language.
Okay, so because version 2 of Python was actually what's called end of life, or kind of killed off on January 1st of 2020, no one should be writing anything new in it. The big thing about Python 3 is it's not backwards compatible to Python 2, and pretty much, unless you have a reason to do otherwise, you should be using Python 3.
Great. So now that we know that we want to use Python 3, we need to decide on where on the computer we will set up the environment for Python. That is, what Python environment we'll be developing in. This only slightly exaggerated flowchart shows one of the main frustrations people have with Python. In fact, just in the run-up to this webinar, I received 4 separate questions that all sort of relate to this flowchart, or at least the topic underlying the flowchart, which is that Python can be installed in many different places via many different methods. And so we want to sort out a specific recommendation for you in this webinar.
That's right, Doug. There are a lot of options here, but for the purposes of today, we're going to discuss 2 main options. One is the Python environment already built into the Mac operating system, and the second is Homebrew, which is what's called a package manager. The built-in Mac OS system Python is definitely not recommended for production use, but it's easy to start using right away. Homebrew is definitely harder to understand as it's kind of a program that manages other programs for you, but Homebrew definitely scales better and is much easier to maintain over time. I will say Homebrew is definitely my preferred method for installing not only Python, but also a number of other programs like ImageMagick and wget. But once again, today, System Python.
That's right. Likewise, there's a lot of different ways you can write the code, a lot of applications in which you can author the actual code where you're typing the code in. And while there's many of them, you should also know you could even use a generic text editor like TextEdit. Python is just words and letters strung together in a specific way, so you could author it in a variety of different applications. What we want to focus on is suggesting two different options that provide a robust set of tools, things like coloring and highlighting text that is relevant to certain parts of the code, formatting, automatic indentation, that sort of thing. So here's the two recommendations we make out of the many, many programs that are out there, many of which are very good. We'd recommend that if it's the first time you'll be writing any Python code at all, especially if you're new to programming in general, use Visual Studio Code in the left here. It is Jeremy and I's opinion that's the fastest and easiest to learn Python authoring software that still gives you a reasonable number of tools to grow with. It's free, it's fast to learn. The other option, and by the way, Visual Studio Code, as we said, that's what we're using today. So if you have not yet downloaded and you want to follow along, download Visual Studio Code at code.visualstudio.com. The other option we suggest investigating is PyCharm. PyCharm's more fully featured, and so will grow with you longer and more completely, but it's also just a busier, more complicated looking application. Both of them have free versions. PyCharm has both a free and paid version. So sort of in order of complexity and tool set, it's Visual Studio Code, maybe going upward. Visual Studio Code is free, basic, easy, not that many tools though. PyCharm free has a little bit more tools, a little bit more complexity, and PyCharm, the paid version, has the most tools, but also the most complexity. Do you think that's a fair statement, Jeremy?
Oh yeah, definitely.
So let's now dive into the step-by-step Visual Studio Code setup, because just downloading it and dragging it into your applications folder is not the end, it is the beginning. So how do we set up Visual Studio Code, Jeremy?
Okay, so if you have already opened up Visual Studio Code, then you may be happy to know that it's one of what's called a packaged program, and you don't have to install anything. Like Doug said, you can literally just take it, drag it into your applications directory. And so when you open it up the first time, my Mac is in dark mode. And so if yours is in light mode, I don't know, but yours might be white. There are different themes, you can set things up, and there's a whole lot of customization. But what we're focused on here today is not making things look pretty, but getting stuff done. So under Tools and Language, you can actually see a number of readily available technologies you can install support for, as Visual Code is not limited to only Python. But we're going to click Python to install support for Python. So when you click Python, you'll be greeted by a little pop-up in the bottom right-hand corner letting you know that Python is installing. Once it starts installing, you may also notice over on the left-hand side this little kind of in progress clock icon. And so if you actually click details in the pop-up in the bottom, or you click that clock icon, you can see how it pops open your extensions palette. And so you can see in mine how Python has been installed. And that's actually the only extension I have installed. Okay. So give everybody a slight moment.
So far we've downloaded the application, dragged it to applications. On the home screen, we've clicked Python, and we've seen that Python has been installed and activated. Great. What's next?
Okay, so now we're actually going to write some code, Doug. So the first thing we're going to do, I'm a keyboard shortcut guy, so Command N, though file new for you mouse people users. We're going to create a new file. And the only thing I've typed in this file is pound or hashtag, depending on when you were born, test.py, and that's on the very first line. Notice it says pound test.py in the tab and in the title bar at the very top. And since we haven't saved our file yet, at the very bottom right-hand corner, it actually says it's plain text. Okay, so Command-Shift-S to do a save as, or file save as. And then when you do that save as, it's actually gonna pop up and it's gonna go ahead and take whatever you had in that first line and add it to the save as box. Okay, so we need to get rid of that pound sign and the space from the beginning of the file name. And then I'm gonna save it to my desktop. I suggest you do also, just because it's an easier place to find stuff right now. Okay, so when you click save, it's actually gonna pop up a whole nother window. Yeah, you get a whole lot of pop-ups right now. So this pop-up should have two different, this new tab should have two different pop-ups in the bottom right-hand corner. The first pop-up that says linter pylint is not installed is about what are called linters, which is pretty beyond the scope of this webinar. So I'm gonna click do not show again, but you're more than welcome to X it and have it pop up later, or dive right in. But I suggest you X out of it, and we're gonna focus on this interpreter pop-up. So right now it says we have selected the Mac OS system install of Python, which is not recommended for use with the Python extension. So it's saying, some functionality may be limited, but let's just go ahead, please select a different interpreter. So we'll select a different interpreter. When you click that, it pops up a new dropdown, and the current interpreter is highlighted. That's always true. And within those options, you can actually see at the top how it you can see how the currently selected Python interpreter is also matched in the bottom left-hand corner. This is always true, so it tracks and follows with the current interpreter that you're using. Okay.
Now, wait a minute, Jeremy, it says Python 2.7. I thought we just got over saying that we don't want to use Python 2. We want to use Python 3.
Exactly. Thank you, Doug. And so we actually want to choose the Python 3.7.3 64-bit. You really want to make sure that you're using the one that starts with /usr/bin/python3 and not one that starts with /library/developer. Okay, once you click that, you'll actually see how your Python interpreter changes in the bottom left-hand corner. Okay, so now at this point, you can close the tab or you can click back onto test.py, whichever you prefer, doesn't make a difference. I'm gonna close the tab, and then it's gonna take me back into test.py. And so I want you to notice first in the bottom right-hand corner that Python is now, we now have Python in place of plain text. And if you look now, we actually have the path for our saved file, users DT lemonade desktop test.py shows at the top. We've got highlighting, and now we can push this arrow over on the right and we get to play. Okay, so it's gonna pop up a terminal window from the bottom that runs the Python interpreter we chose for our script. And I'm gonna bounce back one.
I don't think we actually explicitly stated, and we have now typed in the line print parenthesis, single quote, hello, your test worked, exclamation mark, because we're very excited, end parenthesis. So that was a step that we did not explicitly state.
And if you skip typing that in and you hit play beforehand, it will run and it will pop up a terminal window, just nothing's gonna output. And so that's what happens down here. That's what this bottom section is. So we have a terminal window, kind of palette that pops up from the bottom, that's gonna run the Python interpreter we chose in our script. So if you look in the bottom left-hand corner, back at our interpreter, you'll actually see how that tracks up, and that's what's calling the Python file. It opens a terminal window at the bottom that runs the Python interpreter, and then also calls the same script. And so it's just pasting that information there. So let me point out that yes, our test worked. So hello, Doug. So it was successful. And the great part I think about Visual Studio Code is how all these different pieces fit together nicely and in one location. This is a big reason why we chose Visual Studio Code. While you can write and run Python in a multitude of ways, it's great to be able to do all of it right here.
So, Jeremy, I think now is a good time, since we've written our first line of code and it's worked, to go back to the beginning and just quickly review the steps that we've taken to go from downloading and setting up Visual Studio Code. So we have downloaded the .zip file from Visual Studio Code's website.
And actually, it's not even a .zip. I think it's just
yep. So we've downloaded it. We've dragged it to the applications folder. We've launched it. We've seen this welcome screen. We've clicked on Python and pushed OK. Python has loaded up. We've started a new document, just like you would with any other program like Microsoft Word, starting a new tab like you would in Chrome using Command N or File New. We've started typing into it and then saved it as a .py extension file. Having saved it as a .py extension, it pops up a couple things about Python that we've basically, the first of which we've dismissed, linter. We've just said, don't worry about it. The second one was about the Python interpreter, and it is correct that we want to pay attention to and make a change to the Python interpreter. So we've clicked Select Python Interpreter. Of the options listed, since we don't want to use Python 2, which has been end of life, we want to use Python 3. We select one of the Python 3s. Specifically, we want to pick the Python 3 that has /user/bin/Python 3. If you're wondering what all the rest of those things are, I remind you of the spaghetti XKCD comic that we showed you, where there's a whole lot of different places and ways to run Python. The correct one here is /user/bin/Python 3. We do have a question from the audience I want to address at this point. Is Visual Studio Code for Python just for Mac? I think there's both a Mac and a Windows version. Is there not, Jeremy?
Yes.
A Unix version and a version
I think there's a Linux. Yeah, there's a Linux version too.
Great. Okay, having selected the appropriate interpreter, we have gone back to our document that we started and saved, and we see that it's running in the bottom right, Python, and in the bottom left, we see that it's Python 3.7.3. Because it's running Python, we can now push the play button. When we push the play button, having typed in print hello, your test worked, we get hello, your test worked. Now, you were about to talk about the fact that we're putting together things in one application that might otherwise come from different places. Let's go back to that.
Yes. So this is actually honestly, I feel like probably the biggest reason we chose Visual Studio Code was that we could have people download Visual Studio Code and then work completely inside of this program without having to open up a separate terminal. But we need to access the terminal because we need to install a module, which is a software for Python. Doug's going to get into it later, but I'm going to show you guys just how to do it. Okay, so ignore the man behind the curtain doing all the magic and just follow the directions. The first thing you need to do is where this says Python, go ahead and click and choose either ZSH or Bash. If you're on a newer Mac on Catalina, odds are it's ZSH. If you're on something older, such as Mojave, then it's probably Bash. Once you go ahead and click that, it's going to go ahead and give you a new terminal prompt. At this point, we're going to type in one line. That's it. pip3 install --user pillow. And all this is going to do is go up to the internet, collect the file for pillow, download it, install that collected package, and you can see here it says successfully installed pillow 7.2.0. And if you're following along with the directions we have, you'll also have a wonderful yellow warning text that tells you that you are using an out-of-date version of pip, and they highly suggest that you upgrade it. We definitely, absolutely, 100% agree that you should. But right now, we're just trying to get to writing some code, so we're going to circle back around to this stuff at the end of the presentation.
Great. So In review, to set up, we've downloaded an application, we've installed some modules into it, and we've configured it to use the installation and version of Python that we want. Now we're ready to start writing some code. Jeremy, I'll ask you to do the advancing. So as with our previous part 3 of our DT coding series, we're going to frame this as our boss has come to us with a request. This one's going to be a little bit contrived because if I was genuinely only interested in making a thumbnail from a TIFF, this would probably be a very long way to do it. I will note, for those who have asked about Python 3 versus Python 2, if you're not currently able to install Python 3, I will note that other than the print command, that is all you need to, let's try this again. If you are unable to upgrade to Python 3 during the course of this presentation, you should be able to follow every single thing other than the print command. And when you call the print command, simply ignore the parentheses that we use on screen. So use print without parentheses. Now, moving on to the example. Our boss has asked us to make JPEG thumbnails from this TIFF. Great. And actually, Jeremy, I'll go ahead and take over the advancing. So the first line of code here is just pound example 1A. If you look in the downloaded zip folder that you downloaded, example 1 has example 1A, 1B, 1C, 1D. You can either type this in manually or you can just open up example 1A. The first line, because it has the pound, is just a comment line, does not do anything whatsoever. It's just a label for us and other coders in the future. The next line, line 4 here, from pill import image. Well, we've already reached a breakpoint because we have to talk about modules. What the heck does from pill import image mean? That's totally Greek to me. So let's talk about modules. Imagine for me that we have the ability to simply hire or bring in a kitchen. And that kitchen has a sink, a dishwasher, a microwave, and a refrigerator. And I can simply tell those things to do certain actions or activities. In Python, you would say import kitchen. There's a kitchen out there. Somebody else has done all the work to make the kitchen. I'm just importing the kitchen. Import kitchen. And now from that, I could tell kitchen.dishwasher.load dishes. That means basically talk to the kitchen to talk to its dishwasher to tell it to load the dishes. Somebody else's code, somebody else has figured out how loading dishes work. All I need to do is import the kitchen and then call the dishwasher to load the dishes. However, as the metaphor might be intuitively interpreted, I may not want to import the entire kitchen. If all I want to do is wash dishes, I don't want to import the kitchen. I want to import just the dishwasher. And so that command is similar. It would be from kitchen, import dishwasher. And now you see the difference in this, where everything is highlighted, everything's being imported, versus this, where only the dishwasher is being imported. I can then say, instead of kitchen.dishwasher.load dishes, I would just say dishwasher.load dishes. That's because I'm not importing the entire kitchen. I'm importing from the kitchen only the dishwasher. I hope you're with me so far. This is a way of getting somebody else's hard work into your program so you can just call it with a single line. Pretty much the rest of today is going to be predicated off this concept. There's one more thing here, and that is, in some cases, you're writing the same line of code over and over and over again. So you, or more to the point, an online example that you might see, might rename one of the components that it's importing. So here we have from kitchen import refrigerator as fridge. And the as fridge allows us to address the, for example, unplug from fridge.unplug. Without the as fridge, it would have to be refrigerator.unplug. Doesn't sound like a big difference, but as you write hundreds and hundreds of lines of code, shortening and simplifying the thing that you're referencing can be helpful visually and helpful in terms of logic. Okay, so let's leave the metaphor and let's go to the specific for this case. Pillow, or PIL, is a library that other people have done all the work for. You're able to leverage those people's work for free. It's an open source module. They've done a lot of work that you can just call by importing. The line that we're using here is from pill import image. Why? Because of the many submodules, image filter, image math, image stat, all we're going to need access to is image, a class that defines what an image is in Python, specifically a pillow image or a pill image. And what that allows me to do then is underneath image, I've written 3 of the dozens and dozens and dozens of functions and attributes that you can call without having to do any of your own work. One of those is open. In fact, that's going to be a necessary predicate to most of the things that we do with a pillow image. So the command is image.open, and then the file that I'm opening. Just doing the open command generates an object. I have to put that object somewhere, so I'm going to put it into the variable im, or im. It's just an abbreviation or a shortening of image. Do note, Python is caps sensitive. So if you're typing this in manually rather than opening up example 1a, you will need to make sure that im is lowercase and the I of image is uppercase, or it will not work. So from pill import image, image.open is calling the pillow library image module open method. And I'm giving it a path to my image to open up, and I'm then storing it in im. Not too bad. Now I want to do something with it. And one of the easiest things I can do with it is show it. Under pillow in the image module is a function called show. Once I've formed an image using image open, I can then show it using .show. So here in example 1a, on line 8, you see im.show. It's not image.show because I'm calling it on the specific image that I've created on line 6. On line 6, I created the image called im, or the variable im that holds the image, calling image.open. And then on line 8, that object, that image that I created, I'm showing it. And if I push play, voila, I see an image. Except most of you probably will not see an image. And that is because the address or the location of the file is hard-coded in here, /users /Doug Peterson /big001. So unless you are Doug Peterson or have an account on your computer named Doug Peterson, if you do and you're not me, that's kind of weird. And unless you put into that directory big001 or big_001.tiff, you will not have a file to open and you will get an error message. So I'm going to take a pause now. In the zip download, find in example 1 the folder called example images. So that's inside the zip, inside example 1 by Doug, inside example images, you'll find big_001 through big_008. I want you to copy all of those to your home directory. In the Finder, that's the one with the house icon, usually with your name or the name of an institution or something that you're working at. And you just want to paste them directly in there. Another place on your computer that you'd find, or other folders that you'd find in that same home folder would be desktop, downloads, documents. If you have Dropbox or Google Drive, that's where those folders usually are. So if you're there, you're in the right place. Drop those files in, and then in your code, you'll need to update the home folder name. This Doug Peterson needs to be updated to your user name. I'm going to pause there. We're going to check through the chat log and make sure everybody is copacetic. So, Stuart, you had asked about the Visual Studio showing ZSH or Bash. Let's go back a little bit here while everybody's looking at the other stuff. If we look here, note that while Jeremy's example used ZSH, it could be either ZSH or Bash. The command will be the same, and that is pip3 install -- user space pillow. This command would be applicable even if your first entry there is called bash or bash. What would it be on Windows, Jeremy? Yeah, exactly. We're both Mac guys.
It's been a while since I've worked on there. for those that don't have a bash that they can run this in, you can also open up terminal just with spacebar command and type in the same command into terminal. Sorry, open up the terminal application and type the same command into terminal. You just want to, if there's issues with that, we can try to sort some of that stuff out later too.
Yeah. All right. So let's go back. So we have located the zip file with the examples. We've moved them into our home folder, and we've changed the name in the script to be the name of ours. Great. So we've done im.show. Let's do another thing with the Pillow library. We're going to call on the attribute size. Pillows, image modules, size attribute. And we do that by just im.size, right? We've created the im object, and now we do im.size. When we do just im.size, that would just be a number. We have to do something with it to see the results. So we're going to say print, parenthesis, im.size. If you were using Python 2, you would skip the parentheses. Is that right? Anyway, we're dealing with Python 3. All right. So print im.size, and we push the play button in the top right, gives us 1095 by 1600. And this is going to be another breakpoint for us, because what the heck is going on that we're asking for one thing, im.size, and it's showing us two things in a parentheses separated by a comma. And so we need to talk about tuples. A tuple is a type of object in Python that is a little bit like a list, right, in that it contains more than one thing being bundled up into one thing. So for example, here in this hierarchy, you see size. Size is a thing. What size is that image? But it contains two things inside of size. You can't define size without talking about both width and height. Another analogy here might be coordinates on a graph, right? You have an x coordinate and a y coordinate, but if you have a point on the graph that is a point, it's just that point is defined by two separate attributes. So if you ask for what the coordinates are, you have to have two answers. A tuple, which comes from the word, the same form of the word quintuple, quadruple, sextuple. The tuple is what we're talking about here. That doesn't have to just be two items. So we talked about size and coordinates having two things. You could also have coordinates that have three dimensions, an x, y, and a z. So if you have an x, y, and a z, that would be a tuple of 3, or a 3-size tuple. So the attribute image.size, what we're calling when we say print im.size, is two separate numbers, 1095 and 1600, that are both comprising image.size. And so when we print it, it shows us two numbers, and it shows this to us in the Pythonic way, which is two parentheses, the two numbers inside of it separated by a comma. So we can treat it as a tuple, that is one item or one object that contains two things, or we can break that out and have those two separate components unpacked into two separate variables. So instead of print im size, we could say width, comma, and I am really apologize, the square that I've drawn over here has eliminated the comma, but it's width, comma, height equals im.size. Width, comma, height equals im.size. We'll unpack the two variables inside of im.size and place them into width and height. And then if we print them, print width and print height, instead of having parentheses and two items separated by comma, instead we'll have two separate lines, 1095 and 1600. Okay, so now we are on to example 1D, where we're going to add another layer. In example 1D, we've taken and created a variable called input_tiff, and we've assigned it, quote, /users/Doug Peterson /big_001.tiff, the path to our file. And we've then used that, instead of typing it in again, under image.open. In this case, with only 5 or 6 lines of code, it's not a big difference, but in a much, much longer and more complicated script, you can imagine that if you do have a hard-coded value, like the location of a file, you probably want that at the very top, so it's easy to find and easy to change. rather than having it in the middle of the script. Now we're on to example 1F. We've done input TIFF and output JPEG as two separate variables. Input TIFF is the same as before, and we've created a new one called output JPEG that contains /users /Doug Peterson /small_001. Output JPEG is not used until line 12 when we say im.save. Save is yet another function of the PIL image library. And by saying im.save output JPEG, because it has a .jpeg extension, the image module knows to save it as a JPEG. And so now we have already created, sorry, you skipped me forward a couple slides. That's why I got confused. So here we are on this one. Great. So we have taken that output JPEG name and we put it in im.save and it saves it as a JPEG. If I ran this script right now, if my input TIFF name is correct and my output JPEG name ends with .jpeg, then I will end up with a file on my hard drive of a JPEG. Nothing so fancy so far. It would be the same resolution, for example, as the original. What if we want to, as our boss requested, make a thumbnail-sized JPEG? Well, now we need to define a new size and take that new size and resize the image to it. Now, we talked earlier, what is a size? A size comprises a width and a height, and those two have to be bonded together into a tuple using the two parentheses and a comma. So we don't say new size equals 219x 320. We don't say new size equals 219, comma 320 without the parentheses. We must have both the parentheses and the comma. New size equals the tuple 219, 320. Im.resize is another function of image from Pillow that we can call with a size to resize the image. So here we are, example 1F. If we push play, we will get a smaller file. For example 1G, we assume that we don't want to hard code, like we did with 1F, the size that we're resizing to. This would only work, 1F only works if both the vertical versus horizontal orientation and the aspect ratio of the file is exactly as stated here. If we want to instead base it off the original size, then we need to first load the size, like we did a few examples ago, with comma height equals im.size. That loads the current width and height into from the size of the image. And then new underscore size equals, again, a tuple, parentheses with the comma in between, the width divided by 5 and the height divided by the 5. Now, I'm going to pause here for a moment. I'm going to suggest, Jeremy, that you pause, so that you mute yourself so that your keyboard doesn't interfere. You're such a fast and good typer, man. Is that a good mechanical keyboard? Yeah, sure is. And now let's talk about this script and what happens when you push play, because you're going to get an error message. It's going to be another timeout moment. We have to talk about why this is crashing, or why this is returning an error message. Error messages, especially if you're new to programming, are always going to look intimidating. Often you end up with like the blue screen of death's worth of lines of code that seem totally foreign. At least in Python, usually, fortunately not always, but usually, the last line is going to give you the most English language explanation of what's going on. Type error, okay, so it's an error regarding types of something. Integer argument expected, got float. Programming languages and programmers tend to be succinct in their communication, so this is a slightly hard sentence to unpack, but it's exactly as it says. It was expecting to get an integer, and you gave it a float. So now all we have to figure out is what the heck is an integer and what the heck is a float. And if we can give it the right one instead of the wrong one, the error will go away. So, timeout, what's an integer, what's a float? Python has many built-in objects, the things that you can use to build other things. Text, numbers, sequence, and sets are 4 of those object types. And of the numbers, there are more than two, but we'll talk about two different types of objects that are numbers. One is a float. A float is, in common parlance, something that has a decimal point in it. It is used in situations where a partial value makes sense, and keeping track of partial values, whether they're used in a specific instance or not, is of value and importance. So for example, if you ask me, how old is my daughter? I would say she's 1.5. She's 1.5 years old. It's not good enough to tell you my daughter is 1 or 2. She's 1.5. So I would define baby age as a float, and in this case, the value would be 1.5. An integer is not like a float. An integer does not have a decimal point, and it represents things that cannot be broken up fractionally. So for example, the answer to the meaning of life, the universe, and everything is not 42.0. It's not 42.2. It's not 39.9. It's 42. How many people live in my apartment is not something that should be represented with a float in most use cases. Either a person lives there or does not live there. 3 people live in my apartment. Number of people should be an integer. Now, if you are in digitization, it should be intuitive to you why the size of an image can't be a fractional pixel. An image is 800 by 600, or it's 1024 by 768. It can't be 1024 by 768.3 pixels in dimension. And so because the image dimension in pixels, at least, can and should only be an integer value, the image dot size attribute expects and requires an integer, specifically a tuple of an integer width and an integer height, right? So if we want an integer, we have to force an integer. When we take width and divide it by 5, we can surround that by parentheses and put int in front of it, and it will force the result to be an integer. When we push play, we get an image. It's smaller this time. Lovely. We're getting an image here because, of course, line 15, im.show. So we've taken an image. We've defined the name of the we've imported the module. We've taken the name of the image and the name of the JPEG out as variables. We've opened the image. We've gotten the previous size. We've divided that size by 5, the width and the height, forced them to be integers, and put them into a variable called new size. On line 10, we've called the resize function on our im resize a new size. im.save saves as a JPEG. We've then opened a new image, which is the JPEG we just wrote out to the hard drive and showed it, which gives us this file down here. Now, quick note, the name of the pop-up and the file extension are going to be arbitrary. Just ignore that. That's a function of how things are going on behind the scenes in ways you don't need to know or understand. Okay. So why is it, so this is going to highlight one of the big problems with programming. Sometimes you know your program's wrong because it gives you a fat old error message. Sometimes your program's wrong, but it runs just fine. It runs, that is to say, it runs without an error message. In this case, the code is wrong in a very subtle way. And to explain why it's wrong, we have to explain what int does. So int does not round the number to the nearest integer. If we do int 1.8, it will give us 1. If we do int 1.1, it would also give us 1. This probably won't matter, but it's not right. And if you can imagine making a subtle error like this on a collection of 100 million JPEGs on the Smithsonian servers or something, even though it's only subtly wrong, a subtle mistake times a million objects is, honestly, it's kind of a catastrophe. So we have to be careful with programming, and we have to be careful with programming, especially when the output is going to be really carefully scrutinized. It's not right to downsample something by a factor of 5 and then round the pixel count down, because one of the pixel values like width might go up and one of the ones might go down. We should probably do something more nuanced and considerate in the dimensions. Now we can choose, instead of int, to surround this with round. If I just Google, how do I round a number in Python, it will tell me use round. More on that later. We'll use round. Round 1.8 gives us 2.0. The problem is round 1.8 gives us 2.0, gives us a float value. And what do we need for size? We need an integer. So we're going to compound these two together. We're first going to round 1.8 to 2.0 using round. Then outside of that in the parentheses, we're going to do int to force it to be an integer. So 1.8 becomes 2.0, becomes 2 as an integer. New size equals the outermost parentheses are forming the tuple. Then int round width divided by 5, int round height divided by 5. For completeness, this is correct. Mostly. We'll get to that later. We run this, we get the smaller image, this time with more sophisticated handling of the pixel dimensions. Thankfully, for all of you people sort of huffing breath and going, kind of falling behind, or I'm losing track, this is the end of example 1. I did include in your example download an example 1J final, and that is basically the same code, but I've given it a little bit more labeling, a little bit better structure and organization, and I've printed out at the very bottom, print input TIFF plus bracket, caret, there we go, caret, plus string new size, plus space, plus output JPEG, and that's just going to give you this nice line here where it gives you the user's, the name of the file going in, the dimensions it was transferred into, and the output name. So 1J final is able to be opened up and run, and you'll have that. Now, let's stop here and ask any questions related to example 1 before we go on to example 2. I get a question from Martina. Why was the image a float value before then? Where did I miss the explanation? That's a great question. So why was it a float? Because we divided by 5. So at this stage here, width divided by 5, width on line 7, width comma height equals im size would generate an integer, two separate integers, width and height. So at that stage, they are integers. But on line 8, as soon as I put width divided by 5, Python is dynamically casting that in to be a float value. Because, for example, if I asked, what's 10 divided by 3, you as a human being would just say 3.33333. 10 is an integer, 3 is an integer, but as soon as you start to do normal division with a single slash, it's going to give you a decimal or float value. So inside of here, even if the result would have been a whole number, like 3.0, 9 divided by 3, or in this case, I guess 15 divided by 5 would be a whole number of 3, it would be represented as 3.0 as a float. So dividing with a single divider line in Python results in a float value, even if both things inside are integers. There is, as a side note, a way of doing that kind of division and keeping it as an integer with having a typecast. It's two slashes instead of one slash. Out of scope for this today. Just know that because we used a single slash, the result's a float. If we don't int the float, it will not accept it, and you'll get this error message here. Argument expected as an integer, got a float instead. Thank you for a really good question, Martina. Is there a benefit to keeping a bash if you're going to share with other folks who might be using older OS? That's a great question. So bash is a portal or a way of getting into something. It's a terminal into the rest of the stuff that we're doing today. Having either bash or ZSH as your terminal does not affect the program that you're writing or the environment that it's running on. You will have to, as you get more involved in Python, you'll have to learn more and deeper about environments. So when we talked about earlier, the system installed Python versus a homebrew loaded installer or a Mac ports loaded Python environment, you'll have to get into that more. But for right now, if you shared this code, your computer using bash or ZSH as its terminal has no bearing on the program. True, Jeremy?
For everything that we're running today, yes. There's some little things with
by the time you get there, you
for
would know.
what we're doing. Yeah. You'll get an error if it doesn't work.
Great. Any other questions on example 1? If not, I'm going to do a very quick synopsis of example 1, and then we'll go on to example 2. So in example 1, our goal Our goal was to make a thumbnail. Admittedly, this was a very, very long-winded way of making a thumbnail from a TIFF. When we get to Jeremy's example, we are going to spread that out to something that would actually save time. This would be a very lengthy way of making a single JPEG from a single TIFF. To do that, we want to deal with images, and I don't want to have to write code from absolute scratch that deal with images, so I've imported the pill image library. Importing the pill image library is like importing a kitchen with a dishwasher that you can load without having to code the dishwasher yourself. You're just using somebody else's dishwasher. So here in Pillow, we're importing image. Image is going to have a lot of pre-built functions. You can read the documentation for Pillow. You can also just Google Python, Pillow, and then something you want to achieve, and chances are extremely good somebody will tell you exactly which module of Pillow and exactly which function name and how to use that function, because the internet's just great. As at least in this context, the internet is great. Okay, so then we've gone through various examples of using the different attributes of the Pillow image library. We've covered the difference between integer and float, because in Python's image library, we have to have sizes be integers. We even covered, for the sake of semi-completeness, the fact that we probably don't want to just force it to be an int. We want to round it in some useful way. And then we showed you the final runnable example, 1J, which has more notes and more information. 1H, whatever, the last one. So will Pillow keep the TIFF color profile? So I'm going to answer that, Martina, in the same way I would normally answer any question about programming, which is, if you Google it, somebody has had not just the answer, but a lot more context. The short version for Pillow and color profiles is that unless you request otherwise, it will maintain the input color profile in all the circumstances that I'm aware of. I say all the circumstances I'm aware of because a lot of times in programming, weird things could come up. Maybe, for example, if the ICC profile embedded in the TIFF was corrupted and Pillow couldn't read it, it may give you an error message, or it may strip it out. You'd have to consult the documentation of Pillow of what it does, for example, on that kind of error handling or exception, right? But in general, yes, it does. Okay, so we're going to move on now to example 2. I will warn you in advance, this is going to be longer and more complicated than example 1. To prepare everybody for that, I suggest we take a 5-minute break. It is currently 27 after the hour. We will be back at 32 after the hour after a 5-minute break to work on example 2.
Hi everyone, this is a reminder that we will be resuming at 32 after the hour in about 3 minutes.
Minutes at 32 after the hour. Oh, I see now 1 minute at 32 after the hour. Friends, we'll begin momentarily. Jeremy, you're ready?
Sure thing.
Very good. So we are now on to example 2, working with file names.
Okay, so in this example, just like with example 1, we're going to have a boss's request. So in this example, we have a directory of JPEGs. So you went through and you shrank each one at a time with Doug script. And we want to rename those JPEGs to be a recto verso naming scheme. So you can see here where we're going to take something that's like ABC1, and we want that to be ABC1R. ABC2 is going to become ABC1V. R for recto is in front, V for verso is in back. This is actually a much more complicated renaming situation than you might otherwise expect, because we're also having to change the numbers in addition to just adding a character to the end. Plus, our boss really wants us to be able to turn him back if, for instance, he's like, hey, I gave you the wrong book, or hey, I gave you the wrong book. So, example 2A. Just like in Doug's example, we're going to start with an import. So from pathlib being the module, and this is what's called a built-in, it's part of the standard library of Python. So you don't have to install, or you don't have to go and pip3 install anything. This is just part of Python 3. And so from pathlib, import path with a capital P. And so now we're going to set the directory path. So this is the same type of directory path that Doug set earlier, where he was pointing at, I'm setting a path to a directory, he was pointing a path directly to an image. But if you remember, Doug's was /user/Doug Peterson, but that's not what I'm using, but I'm still wanting to access the same directory. I'm wanting to access that user directory. But I don't want you guys to have to go in and change and retype stuff. Plus, if I want to be able to give this to somebody else to run, I want them to be able to immediately use this without having to go in and change as much code, change as little of code as possible. And so then at the bottom, we're going to go ahead and print that directory path. And so we can see here that when you do print dir path, and at the bottom, user/dt lemonade, just like if I had hard coded in the path.
And of course, that means if somebody runs that at home using example 2A, they would see their user folder name, not DT Lemonade.
Yes.
Unless their username is DT Lemonade, which again would be pretty weird.
Okay, so now we're going to start stacking things up. So example 2B, we're not just going to access path.home because we don't want to just get into the user/dt lemonade directory. We actually want to access our test book directory. And we not only, sorry, started with not only, but this is one of my favorite things about Python 3.6 that came in, what are called F strings. And so you'll see at the beginning of that statement, it says print, open parentheses, F, and then a single apostrophe, and then colon, dir path, or not, curly bracket, dir path, curly bracket. What this does is it lets me directly call the variables in my print statement without having to really change anything else and make sure did I add the right set of spaces after things? Do I have everything in the right spot? For me, it seems to be much more straightforward to be able to read straight across and only see the stuff that I'm looking for. And so when we print this, we get the output that's at the bottom. Okay, and so I'm going to go back and I'm going to unpack where this output came from. The first part is that we went ahead and we took path.home and then we did join path. And so what that's doing is that's just, hey, this is the next part of our path. Python just automatically adds it for us correctly. And so if you're on Windows, it would automatically put the slashes, I'm going to go with the wrong way. And in Linux and in Mac OS, Unix environment, it's going to put the slashes the other direction. So it's what's called a Windows versus a POSIX path. And so we're actually going to take that, call it in the dir path, and you can see it in our output at the bottom, where now it's calling user/dt lemonade/testbook. And so when you call the same code, it will call your /user/ whatever your username is /testbook. Okay, but what about this part? And what's with this false section? So what this is I'm actually saying, hey, at this path, this directory path, does this sucker even exist? Because just because I type and I create a path that I tell Python to print back out to me, it doesn't mean that anything actually lives there. And so that's what I wanted to do here. And of course, there's not actually a folder there. So no, it's going to print false. These are the types of checks that you want to be doing up front. So you do error checking so that you don't do things like go into the wrong directories and move or rename all the things you don't want to. So now we're up to example C. The first thing I did is that I changed my directory path to the correct directory path where I actually have my test book. So now we're taking path.home and we're joining the desktop and test book. I could have included these with a slash between them and just had one string that I added, or you can stack them up with commas. Really doesn't make a difference. Python lets you do it how you want to do it. And so then we hit this list. A list in Python is a sequence of items, much like a tuple, but we're going to spend time using them as opposed to defining them today. Suffice it to say, lists like a to-do list, like lists are like a to-do list, a shopping list. It's a collection of items you need to keep track of, and you're going to do something with it. So what are we actually doing with this list? We're actually taking dir path and calling what is one of my favorite commands in programming, which is called glob, because it just sounds like blob, and that's what I feel like it does, where you're globbing all the stuff in. And so what are we globbing? We're globbing everything that's a .jpeg, right? That asterisk at the beginning says, hey, we don't care what characters are there and how many of them are there, but it's got to end in .jpeg. And then we're going to make that a list. So now we've got this list of paths to all these JPEGs, and we're just going to say, hey, we got a list of them, right? Makes sense. But then we can call that list below. And so you'll see the command that I'm putting on the front of that. And I know I'm just stacking stuff up. But this one is, and hopefully you can get it from the context clues of this print statement, number of star.jpg is len JPEG path list. And so this is short for length. And what it's going to do is tell us how many we have, how many are in there. So when we print this, we actually have two print statements, and those are going down to the bottom where we have two lines that are printed out. And I'm going to separate both of these so you can see them. And so the first print statement is looking at what our directory path is and whether or not it exists. And this time it's true. The second print statement is actually taking our JPEG path list and printing out the number of star.jpg :space. Yes. Oh, and then the number that we have is 20. Okay, so this is how we're able to get up here, right?
Okay, so now let's just clarify that in the downloadable zip, in the example2 folder, is a set of 20 JPEGs in a folder called example images. So that's the main download of the zip, example2, example images, and there are 20 JPEGs there. If you are trying to follow along, you would need to place those 20 JPEGs into your desktop inside of a folder called test-book. I will admonish one more time that Python is caps sensitive. So it needs to be test-book without caps. Desktop on Mac OS, at least by default, is a capital D. So it has to be on your desktop in test-book. If you have 20 JPEGs, anything that ends in .jpeg, and by the way, this again is sort of an attribute of programming in general, it is possible to have a JPEG have an extension .jpg or .jpeg, and you could have either of those in either lowercase or uppercase, or maybe in some really weird scenario, some mixture of upper and lowercase, like capital J, lowercase pg. Those would all be representative of situations that would not be handled by the script as currently written, but could be systematically handled by more and more and wider and broader code. Mm-hmm. Because we're giving you 20 JPEGs and we're telling you where to put them, and we know those JPEGs have a .jpg lowercase extension, we don't have to worry about that stuff today. I just wanted to stop and remind everybody that this is all predicated on the fact that underneath all of this code, your computer actually does have the things that it's pointing towards, right? I know for me, at least, when I'm approaching a totally new programming topic that is maybe at the edge of my capabilities or previous experience, I often think that I'm having a problem with it as opposed to some super, super silly, simple thing like, oh, well, I don't actually have JPEGs in that folder, right? Oh, Cindy points out that you have 18 JPEGs, and that's totally my fault. I just wanted to make sure people were paying attention. It is 18, not 20. So you would get 18, and it would say number of JPEGs.
And the script will totally work with 18, not a problem, but you will have a different output down there.
And just so you know, you're not totally dazed and confused, files, I think 11 through 18 or maybe 9 through 18 are just duplicates of the first 9 because I didn't have enough JPEGs on my computer sitting around. Okay, thank you very much for that, Cindy. So we've got 20 JPEGs, or sorry, we got 18 or 20 or however many JPEGs in a folder. It must be on the subfolder called test book. We've written this code that gets the directory path to home, adds the desktop and test book subfolders from the home path. It does a check and then prints out that check as to whether or not files are there. It creates a list of JPEGs inside of there using the glob command, using the asterisk, meaning anything at that location that ends with .jpeg. So anything, .jpeg.
Lowercase.
And then prints the number. Oh, yes, correct. Lowercase .jpeg, and then prints out the number of files. Okay, great. So now what?
So now it gets yet another new thing. So now we're going to add what's called a loop. So earlier Doug had talked about, oh, we can do things in batches, and hey, it's really silly to just sit here and run the same script over and over again with just changing for the different file name. So that's what we're now going to talk about. This is how to do things in batches. And so the code is for JPEG path in JPEG path list, new line. And this is what, if you're writing in Visual Studio Code, it will automatically indent you. Python uses indentation to show different blocks of code. So other languages might use end characters. They might use like an end character, or they might enclose things in a bunch of different characters, or they might use an end statement where like for, and then at the very bottom it says end. Like tell and intel, like is used in AppleScript. And so Python just uses indentation for this.
Or an accent, or that I've never heard it said, I would have said indentation.
Indentation? No, I'm just talking quickly. I have indentation actually written down, but it doesn't look like my my note cut that end of the word off. Okay, so we're going to talk about how this actually works. So what we're going to do, and this is just like, you know, like before we talked about how our list is like a shopping list or a to-do list. We're going to start, and we're going to do like, when you go through your shopping list, you're going to buy the first item on your shopping list, and you buy the second item, and then the third item, and then the fourth item. And we're just going to go with, you get them in order, right? You know, like you start at the top and you buy them down. And so Python does the same thing. And loops are a really basic programming structure that you'll find in every programming language. And so what we're going to do is for JPEG path and JPEG path list. So we're going to get the very first item in the list of JPEG paths to our JPEGs, okay? And I apologize, but I'm just going to throw you right into computer science stuff because it would be incorrect for me to say they start counting at anything other than 0. And so the first item in our path, or sorry, the first path in our list of JPEG paths over on the left, and I've just named it as 0. And then what happens is that JPEG path gets brought into where that indentation is. And then all the code that's in that indentation block is run using that JPEG, that first JPEG path from the JPEG path list. When it hits the end, we have used up the JPEG path, the first one. We're going to go back up to the top of our loop, and we're going to start again. But this time, we're going to grab the second path, which is labeled 1. Okay, just to go back real quick. So we're gonna take everything that's in our path list of JPEGs. We're gonna get the very first one. We're gonna run it through our print statement. Then we're gonna go back up to the top, get the next JPEG path, run it through our print statement, back up to the top. Then we go back down, get the next one, run it through, and then we've hit the point where we don't have anything else to run. The script is over. Okay, so down here at the bottom, we have our output. When you run this, if you're running things, depending on the speed of your computer and what it is you are doing, you may or may not see them pop in one at a time. It's actually going through and doing a print statement for each path before it goes back through and does the loop again. Okay, so somebody may have noticed, because this is another one of those little things that can trick you up. These are not in order. So it starts with small 17 to 3 to 7 to 13 to 12 to 6. In Python, unless a list is sorted, you cannot assume it is in any order. Even if I run it again, I can't even assume it will pop out in the same order. Yes, yes. You have all of them. You don't know how they will come out, unless you put them in yourself or you end up sorting it in a certain way that you prefer. And so that's what we're doing with example 2D. All we're doing is just replacing list with sorted. And then at the bottom, because this JPEG path is really, really long to read through, I'm replacing JPEG path with JPEG path.stem. And so that's going to give us what we need right now, which is the small underscore and whatever that number is, but we have the exact same path and we have the exact same file type, so we don't need that information. Okay. Oh, okay. So when we hit play and we run this one, on the top, you'll see the sorted section is pointing down, and you can now see this is the second half of the directory of images. So we start with small 11th and 12th and 13 and 14. And then the second arrow coming down is just to point out that we no longer have this big long path there. It makes it a lot easier to read through, especially if you're having to look for inconsistencies or deal with things. Make stuff that's easy for you to read and that you can understand. This gets just honestly, it's a lot for me to look at. This is a whole lot faster for me to handle. Okay, so now what we're gonna do is we need to split these JPEG paths apart. So what we're gonna do, and then we're gonna print it out again, and I'll show you both parts so you can see it. So what we're doing is we're actually taking that JPEG path dot stem, which you can see down in the bottom left corner from what we've run. So that's our JPEG path dot stem. And we're gonna split that value, and we're gonna split that value on an underscore, okay? And then Doug already did the unpacking stuff later. We're splitting it, there's only one underscore, and since we're splitting it on that one underscore, we should have two values. If you end up having more than one underscore in your file names, then this possibly or probably will not work. Okay, so when we split this apart and then we hit play, we end up with the identifier of small and then the index still in order. Please note that when we split this apart, we actually removed the underscore, okay? So if you need that character back or you didn't want to remove that character, then you might need to come up with a different way of splitting these or just add it back, which is what we're gonna do later. Okay, so this is probably a good point at which to remind everybody why we're doing this. We are wanting to rename a directory of JPEGs to get that recto verso naming scheme. Well, you know, we've got it to the point where we've split them up, but we still need to get the numbers. Okay, so how do we do that? And this is what we're going to get into next. Right here, you'll see that we round. Yes, Doug? Oh. I was gonna say, so just like before, similar to Doug's example, we're gonna round this index, we're gonna cast it to an int, divide by 2, and then round. But there's a difference in terms of what I'm dealing with and what Doug dealt with.
So let's take a time out and talk about casting from string to number, why it's necessary, and how to do it. So how many ways are there to say 5? Well, we talked about Python having different objects, and an object type can be text, and that text can be, for example, quote, 05, quote. The quote indicates that it's a string, just like .0 would indicate that it's a float. So we're saying the string, the letter 0 and the letter 5. That could be a 5. So could the string FIVE. So for that sake could be V for Roman numerals. And in fact, if you're creative, you could probably come up with another half a dozen ways to represent 5 in text form. But it's very, very problematic to keep a text version of a number when you want to do something mathematical to it. What is, for example, V divided by 5? I don't know if that has any meaningful answer. So we want to cast the string 5 into something we can do math on. And if we just take quote 05, that's a string. If we do int quote 05 quote, that will transfer it into an integer. So the 5 is still 5, but it's now an integer 5. If we take int 05 and divide by 2, as Martina's question earlier indicated, the single slash divider is going to then result in a floating value. So it won't be rounded to the nearest value. It won't remain an integer. The integer of 5 divided by 2 will become 2.5, which is a float. So if we want an integer outcome and we want it to be rounded to the nearest number and we need to start with a text value, then we say round int 05 divided by 2, which becomes an integer of 3. There you go.
You Doug? And so that's what we're doing here, because we actually have a string of 011 or 012, and we want to round that and then set that as our new index value. And then print it. Okay. I'm going to zoom into this corner because I want you to see that when we used round and we printed things, the built-in round function is not using the normal arithmetic definition of rounding. It's going to give you a quirky result because it's based on probability. So instead, we are going to use a different function entirely, so we don't have to deal with the set. Sorry, I should point out, it says small underscore 6, which it gave us from dividing 11 in half, and gave us small underscore 6 for dividing 12 in half, and it gave us small underscore 6 for dividing 13 in half, which we only have a recto and a verso, so I'm not really sure how that's going to work, and we only have one small 7. So, quirky results, right? So the easiest thing to do in this situation is actually just to grab another standard module from the Python standard library. So we're going to go up to the top, add import math, and we're going to replace round with math.ceil, C-E-I-L, which just stands for ceiling. And so basically, we're forcing it to round up every single time it's not a whole number. And when we run this, and then we're going to zoom in again, now you see we actually get the result that we're wanting. So we've got 11, image 11 would then become 6 recto, image 12 would become 6 verso, image 13, 7 recto, 14, 7 verso, and on and on. But we still don't have the recto and verso section. So now we're going to add some new code, which is going to introduce 2 new things. Right here, we're going to do an if statement. But with this if statement, you'll notice there's a % sign in there. And Doug, am I trying to take 2% of my index number?
So the % symbol in Python is being used for a type of mathematical operator known as modulus. Modulus is a mathematical operator like plus or minus or divide or raise to the power of that does a specific thing that must sound very, very complicated. Modulus, that must be very complicated. Actually, it's literally first grade math. By that I mean, do you remember in first grade when they had you doing long division? You had to type, write the thing, and then you're dividing 2965 long divided by 3 to get 988. I had to ask Jeremy which one's being divided by which because I couldn't remember all this stuff. I literally did this last time in first grade. Well, turns out the remainder at the end, a remainder of 1, is what the modulus is. When dividing using long division, the remainder is your modulus. So taking 2965 modulus 3 would be 1. 2965 in Python, 265 % symbol 3 becomes 1. 9% symbol 2 becomes 1. And 10% symbol 2 becomes 0. 9% symbol 2 becomes 1 because 9 divided by 2 in long division first grade terms, you get 2, 4, 6, 8, 4 with a remainder of 1. You can generalize this. One of the most common uses of modulus is even odd dividers because any odd number mod 2 is 1 and any even number mod 2 is 0. So mod 2 can be used as a stand-in for is even or is odd depending on what the result is. Here is his code. If index mod 2 is 1, it's an odd number. Else, it's an even number. Pretty straightforward. And now first grade math is finally useful again. You can tell your first grade teacher you learned something you did in coding.
And we'll also, and the word parity, which is what we refer to as those 2 types of values, odd and even. So what we're going to do is if our index modulus 2 is equal 1. So we're not setting a value. At this point, we are actually what's doing a comparison. So we are so 1 equal sign sets the value, 2 equal sign actually does the test. And so if our index modulus 2 is equal 1, then we know it's odd. And there's not really a reason to test anything else. This is one of those nice situations where, hey, if it's not even, it's odd. Or sorry, if it's not odd, it's even. And so it actually would take more, it would take more code and slow our program down to make another test to see if it's even or not. So instead, what we're going to do is we're going to take those values and we're just going to stick it onto the end of our stem. And so new stem plus parity. And then we're going to take this sucker and we're going to print this guy out. And so now we have something, and I feel like we're getting a whole lot closer, you know, because now we have small underscore 6 odd, small underscore 6 even. And just a reminder of where we want to take this script one more time. So we want to have 1 becomes 1R, 2 becomes 1V, 3 becomes 2R, 4 becomes 2V. And that's what I've thrown in here. Okay, so what I've put in the block, the red block demarcates everything that's changed in this new script in H from whatever comes before H, G. So the first line, we're going to set our new stem, and then I've actually gone in, and you'll notice now that we're taking our new index and we're casting it as a string. Just like int is for integer, str is to cast things as a string. And so what we're going to do, it has to be a string. It has to be a string because we want to zero pad this sucker back. And you can't have zeros in front. You can't have 0, 1. 0, 1 is not an integer. So we have to have a string so we can zero pad it, which is a super easy value or a super easy method to apply, where you just do .zfill and put in the number of digits you want. So we can now take our identifier with our new index that's 0 padded, and we're going to take that sucker down. That's our new stem, and we're going to move it down to the bottom. Okay, so we're going to come back to that again in a moment, because what that does is we're going to redefine what new stem is after we get odd or even. So we're going to take that same int index, and when we do the modulo on it, we're going to have it either be odd or even. And at this point, I went ahead and changed the variable that we're using, the variable name that we're using to be page instead of parity. And we're either going to use R for recto or V for verso. And then once again, we're going to redefine new stem as the old stem and just add this page onto the end of it. So once again, we're going to take the new stem, bring it down, add the page onto it, and then when we print it, we actually have, so we are now at the point where we have the values that we want in terms of being output. But I am sorry to say that just having these values output doesn't actually mean we change things on disk. And so this next slide, okay, just warning now, the use of the value, the function rename will rename things on your computer. There is no, it will overwrite things, and there is no check to see it. It's not going to ask you whether or not you're doing it correctly. That's why
the gloves are off.
Anytime you do anything like this, that's why you always want to start with these little toy exercises, because I always start here and then go up. And anytime I'm adding a new feature, especially any new feature that's going to rename, delete, copy, move stuff, especially across a network, and especially when we're dealing with lots of files, I don't want to have to do it all again. So it's very important.
Can I quickly state here the terminology that most people use once they get into coding, which is development and production.
Mm-hmm.
In general, when you're testing new code that has consequential impact on actual data, It's not just printing things to the screen, but it's moving files or renaming files or changing TIFFs or resizing something. But there are two rules of thumb. One is that you never want to be working on the live data during development. And the second is to have backups even independent of that. So development computer, many people would have one computer, physical, literal computer that they're using for development, and they would keep it separate from the computer they're using for any production work. And only code that has been tested several times, preferably by more than one person, preferably in a variety of situations, would go from the development computer to the production computer. That is less important when you're just getting started and doing only things like print to screen, but it's especially important at the beginning when you're doing things like renaming, because as Jared mentions, if you were to do a rename command onto a folder that was otherwise full of things, you can just totally scrub an entire week or month or a year's worth of work in one instance. And if you ever need examples of this, just Google programming disaster overwrite and just read many people's various sundry problems they've created for themselves. I know one guy I follow had an entire year's worth of work wiped out by a single missing character in an SQL command. And anybody who's been programming for a long enough time has an example of that. Usually one example of that, because you learn darn quick after. This is just your cautionary note that you don't have to have one to learn that lesson. You can do that. You can learn that lesson right now and never have it happen to you.
I've definitely done that in the past. Okay. So
where we left off, we had the lists formed, but we haven't yet done any renaming of the disk.
Correct. So we've printed out the list of what we want now. And what we need to do is actually get this path. Yeah, we printed that out. That goes there. Oh, I think we're both. It's catching up. There we go. Okay, so the first thing we will need to do is set our new path by joining our directory path. So that's our original directory path with a file name made out of the new stem and the JPEG path.suffix, that's just what the extension is called. We used JPEG path.stem earlier, and so I wanted to go ahead and give you guys the value to also programmatically call the extension, which is .suffix. This will rename. If you're not sure about wanting to do this yet, you can also put a pound sign at the beginning of this line and replace that, put that whole thing inside of a print command. That's a lot of times what I'll do when I'm testing things out. But let me show you where we get these two parts. So the JPEG path is the original JPEG path that we globbed in our original list. And then the new path is everything that we've worked up to until now. So we can create all that and then do what is one of the shortest lines in the whole script. JPEG path.rename, new path. I feel like it's anticlimactic, kind of like shooting large format. Get the leaf shutter going off. Okay. I took the print statement for this one and I put it inside of another if statement, because this time before we print and say that it is this new path, we actually were going to go through and just like how we used exist before, we can say is file. By using is file, it will only give us a true value if it actually exists and it is a file. So if it's a directory, it will not print out for us. And there is also a is dir. So if you want to test and see if things are directories that way. Okay, so now when we print that out, we will actually get all of our files to be renamed correctly. And here we can see all of our renamed images. Here is our script. Just like Doug had done with his script, I went ahead and added final and went ahead and then added more comments to just kind of give a bit more idea about how things are working. And then I'm actually seeing some mentioning there about, hey, can we undo stuff? Well, if you remember correctly, that's actually what my boss said is we need to be able to undo this. And so I've included example 2K. Example 2K is not commented, but example 2K will take the value you output from 2J and turn it back into what you started with. So having these two scripts will let you push and pull things back and forth. I will also leave it to you to see if you can figure out the logic that you would need to use to correctly rename the files without looking at my script.
One, we accomplished something that would have been much faster to accomplish by 5 different methods. Open the file in Photoshop, open the file in Preview, open the file in Capture One. In example 2, we extended that to a search, a glob, that did it on a whole bunch of files. And that would have been on par, depending on how many files in the folder, compared to doing a batch script in Photoshop or running it in Capture One. You can imagine that what Jeremy just did can be turned into a script that, instead of just looking in one folder and pulling all the files, would do a folder of folders of files. And so it could do 200 books and every file in the book with one button push. Developing it certainly takes time. Testing it and bug fixing it takes even more time, but then deploying it yet again is effectively free. So as we mentioned in our part 1 course, it is that redundant or repetitive, boring, simple action that is the easiest, lowest hanging fruit for automation. And Jeremy's example starts to touch on that in Python. But we're going to be very frank, obviously in one class here, even though we're going to be pushing on 2 hours or something worth of class or 3 hours worth of class, that's not going to be enough to teach you everything there is to know about Python. So now we need to talk about what are the next logical steps if you want to go deeper. Well, first and foremost, development is kind of like driving. Comfort matters and customization matters. So you'd want to, as a next further step, start to tweak your setup that you're using to develop. For example, you would want to add and maintain comments to your code. You would want to look into what's called a virtual environment or a containerization. Those are separate and related thoughts there that allow you to basically put a box together with all the modules that you're drawing down for a certain project. So far today, we've only done 2 examples and we used mostly the same modules, but you can imagine that you could end up with 12 or 20 or 200 projects on the same computer. Some of them need the kitchen sink, some of them need the kitchen faucet, some of them need the rec room gym equipment, and you don't necessarily want to have in any given environment all of the things from everywhere. Moreover, your current project for renaming files maybe uses the version 2020 fridge, where the one that you've been maintaining for resizing images actually uses the 2019 fridge. So instead of having to try to have 2 fridges in the same place, you could have a big box in which you put all the stuff, the container for your first project, and a separate box or container for the other. That's probably a somewhat confusing explanation. My point here is that you'd want to continue to research the topic of virtual environment or containerization, learn and understand them, and start to implement them. You'd also want to learn to become what they say is Pythonic. Nobody is a native Python speaker, but some people are more fluent than others. And fluent Python code looks, is shaped, is formed, and is styled in certain ways, such that someone else can look at your code, and if you've followed those conventions and your code looks Pythonic, they will be able to understand the code more readily. Even better, because you've learned to be Pythonic in the way that you read and write code. When you look at somebody else's well-shaped, well-formatted code, you'll be able to understand theirs faster as well. The thing that you would Google is PEP 8. That is a style guide, or watching synopsis videos of the most important things from PEP 8, because PEP 8 is not a short document. But whenever you're starting to do some new thing you've never done in Python, Google PEP 8 and then that thing. Oh, what is the PEP 8 way of doing for loops over a list? What is the PEP 8 way of doing, please?
And I wanted to bring, so that takes us, the thing that we click, don't show me again at the beginning, the linter, that actually helps you go through and kind of enforce some of these style guides. So you don't have to do it all yourself.
Right, especially when it's like literal spacing or capitalization, that sort of thing. Okay, updating. We emphasized at the beginning that you, when you're coding and you're giving access for code to do things on your computer, staying up to date with that code in order to avoid security holes is important. At the very beginning, we presented the fact that you'd want to update the pip3 installer, and we just kind of skipped over that, but we agree that that's an important thing to do and a good next step. Customization. Whether you're going to end up using Visual Studio Code or PyCharm or something else entirely, all of those programs have some ability to adjust, if nothing else, literally the size of the font on the screen being used to draw the lines of code. If you can't see it clearly, you probably want to make it bigger. If you can see it clearly on a big monitor and you want to make it smaller, you'll have more room. Small things like that are quality of life, but again, coding is like driving. If you're more comfortable, you do it better, I think. Settings in those programs, keyboard shortcuts in those things also matter. Certainly the more comfortable you are driving, the more you want to drive. Okay. Version control. Again, we've only had 2 examples, but in those examples, you can see that we ended up iterating over and over again, making small changes. Even PhDs in computer science, when they go to attack a medium difficulty problem, break it down into smaller iterative development steps. You don't sit down and write 80 lines of code at once. You think, I need to do X, Y, Z. You put some placeholders in place to say, I'm going to need to do X, and then Y, and then Z. And then you tackle X, and you push play, and you make sure X is happening before you go on to Y. As a general rule of thumb, that's how development goes. Then you have a fully fledged, ready-to-go program, and then somebody comes and says to you, oh, but could you is one of the most dangerous ways anyone can start a phrase. Oh, but could you just make it also work for X? Oh, but could you tweak it so that at Y, and you make some change to it.
Is that the
2 years later, exactly, 2 years later, somebody comes to you and says, I like the way it was a year ago. There's 1,000 reasons like this that you'll need it, but you'll need some sophisticated way of doing version control. You don't want to be, as we did, saving 1A, 1B, 1C, 1D, because after 26 letters, you run out of letters. And after 2 or 3 digits, you start to run out of any ability to remember in your own brain. Oh, that was around version 300J. So start to Google around, watch videos on, research the topics of Git. That's G-I-T, like get it from the repository. Is that where the etymology of Git is? I assume. Like go get it?
Mm-hmm.
Fair. Okay, so incremental branching backups is another thing to research. Git. Now, how would somebody learn about Git, Jeremy?
Well, if they're attending MCN in November, Charles Walbridge of the Minneapolis Institute of Art and I are actually teaching a 1-hour workshop as an introduction to GitHub for non-coding cultural heritage professionals. And so Charles is the lead collections photographer at the MIA, and we are putting together a very introductory thing to what Git is and how it can be done, even and what it's useful for, even if you're not a programmer or writing any code.
Mm-hmm. Great. Now, other resources and community stuff. I think we should emphasize here that coding almost always takes place at 3 distinct levels. And this is what the question was we asked in the poll. Have you used someone else's code? Have you modified someone else's code? And have you written your own code? Even if at the end of this, you determine that either for efficiency and job responsibilities and scope, that you never want to code from scratch, it can still be very efficacious and efficient to learn to make a small tweak to someone else's code. So for example, if you look at Jeremy's code and it does the RV for recto verso out of a folder of JPEGs, but let's say that you wanted to do TIFFs instead of JPEGs. Well, then if you followed along today, maybe you could write all of this from scratch, starting from an empty window. Maybe you'd really struggle to do that, but presumably it wouldn't be all that hard for you to look through that code, and now it wouldn't be as intimidating to just look at that set of lines of code, find .jpeg, and replace it with .tiff. It also gives you, by the way, in my opinion, more, I would call it buying power, more sophistication of consumerism if you hire out that work. If you know this script works exactly as is, but I just need to change it from accepting JPEGs to TIFFs, that gives you some sense if someone comes back with a quote for $10,000 to identify where you're confused of what you're doing. So I think that's a really good element of learning to code, is just remembering that you don't have to be able to get all the way to starting from an empty document in order to have coding be a useful part of your life. Now, what other resources and community code can you build off of? Well, obviously Google is a great place. Python is one of the languages we chose for our series because Python is incredibly popular, especially the last couple years. Incredibly popular. If you Google Python script and then some common task on a computer, 20 people have written scripts about it. 3 people host a website where they've discussed the difficulties of the problem and how to solve it. And most of it's going to be free and open source. So if you want to rename a set of folders based on some specific need, you can find somebody's code to do it on Google. Normal caveats that running someone else's code, you should at least be able to skim it and understand it well enough to know that it's not, for example, maliciously going to delete everything on your computer or something. But generally, you find it on a good website from a reputable source, other people's comments, etc. It's pretty safe. Stack Overflow is like Google, but specifically for context of programming stuff. GitHub is a place that people put their projects up. It's one of those repository or version control systems that we talked about. Jeremy D. Moore has his own GitHub page there, and all of the code. Jeremy, is there any code on that is not open source? Hopefully not, if you put it into a public repository.
Yeah, all of the public. I don't think I have anything that's private. I think I have.
And you would encourage anyone to start with that code, contribute to that code, make their own version of that code, ask questions about that code, etc. Great.
Yeah, I would love to be engaged and have people fork stuff off. And
fork is to create a new version of that has a slightly different impact or purpose or development life. Okay, classes and consultation. There are, needless to say, 1,000 of these out there. Jeremy and I talked, and we think that if you're going to spend time looking at 1 or 2, we would suggest RealPython and PyImageSearch, which provide really good websites with practical, understandable, useful Python code.
From beginner stuff all the way through machine learning, artificial intelligence.
As far as consultation goes, both TT in the form of myself and a few others here and Jeremy would be available for consultation. There's also plenty of other Python consultants out there. Python is a general purpose language. I would encourage you, when looking for and hiring a Python consultant of some kind, ask about their specific experience with whatever your thing is. Digitization, images, file folder structure, SDKs for online APIs, whatever task you're trying to accomplish, try to look for Python plus that task, because you could hire a Python programmer that has no image experience whatsoever and is incredibly good at something totally different. Okay, the DT coding series capstone, of course, which will be coming up in 2021, I think is a great place to get deeper, especially into digitization specific topics. We'll talk about those topics in a short bit. And then finally, even in the period of COVID, don't discount the possibility of in real life or IRL learning. Jeremy is part of a club. Would you like to talk about that?
For Python, and I've actually found that there's a number of folks. This is not uncommon, especially in any area where the next thing Doug has there. If there's a university in the area, there's probably a local meetup. But there's yes, go Vols. That's actually an area that I've started to engage with quite a bit. And it's one of those places where it's a Slack or a Discord, and there's usually somebody somewhere online at any time of the day that is not only able but willing,
most especially at 4 a.m.
Yeah, it is. It's amazing how giving programmers are in terms of wanting to build community and make things that work.
And of course, we should give a shout out to your local library, as libraries have transformed themselves to be service hubs of various educational and community programs. Many of them do have programming specific either meetups or groups, or just the librarian there will have some Python experience. Again, Python, if you've not been privy to this before, is wildly popular. You'll find people in all walks of life using Python to solve their problems, and it's very possible your local library has somebody who does it. And if so, chances are very good that if you're polite, they will be very glad to help you almost limitlessly, because librarians are awesome. Go librarians. So finally, let's take a look at the capstone as far as topics go. If you want to dive deeper, we mentioned, of course, that the online webinars we've done have been intended for a beginner level, have been intended for a beginner pace. It's not that the capstone jumps to like a PhD or anything, but it is the capstone intends to dive deeper and go a little bit faster for people who felt that the webinars were comfortably paced. Then you will feel good about the capstone. If you felt very behind as you went on the webinars, probably the capstones would require you to spend a little bit of time before the capstone to take. Using the capstone curriculum, we'll be talking about things like interactive programs where you ask information from the user, maybe a file extension or a book name or a barcode value, interact with applications such as Capture One, using combinations of Python and things like AppleScript, or using interoperable formats, CH processing tasks like PDF compilation, metadata, and OCR, and validation tasks, that is checking to make sure the file format and the file names and the file structure are all correct using things like OpenDice, Jove, and Baggett. I am so glad to say that anybody who's made it to this point, 3 hours into a topic of Python, has our free and undivided attention until I have to go pick up my daughter from daycare in order to ask questions. So I'm going to jump over to the questions dialog, see if there are any. There are currently no unanswered questions. There we go. What kind of contributions to coding for CH are you looking for? Notebooks, routing tools. Okay, great. So I'm going to turn that over to you, Jeremy.
Yes, absolutely, 100%.
I'm sorry, Jeremy, for the sake of anybody watching this as a replay, could you please ask the question?
What kind of contributions to coding for CH are you looking for? Notebooks only. We wrote a tool to isolate images contained in sleeves of slides using scikit image and would like to share. And so that's from Martin or Martine. I apologize if I'm butchering how to pronounce your name. And yes, I mean, honestly, at this point, I'm just starting to wrap things into coding for CH. And I've been going very slowly, one, so that we could try to start to build them a bit slower in terms of like the README and like how to install and getting started. But definitely, there's no reason we can't start throwing all sorts of advanced things hidden away, like for instance, into the notebook section. My long-term goal is actually to plan on making this a pip installable thing. Doug? What
is coding for CH and how can someone find it?
Oh, Coding for CH is an open source repository that I have on GitHub. It's at github.com/JeremyDMoore/coding4ch, I think, right?
And to clarify, to contribute to that effort, if you are a coder with lots of experience, that's great. If you're a coder with a little bit of experience, you can still help. And if you're somebody with absolutely no coding experience at all, and today was all just kind of fuzzy for you, you can still contribute. Contributing in different ways, of course. You can, for example, simply join discussions about what problems your institution is routinely tackling that you think coding might be helpful for, and basically you're suggesting problems to solve. If you have a little bit of coding experience, you'd probably be very well suited to test the code that's deployed. Somebody says this code should do X, download it, try to follow the instructions, and either find that the code is wrong or that the instructions are insufficiently clear because you are the target for this, and you can contribute in that way. So contributions to that effort as spearheaded by Jeremy are welcome from just about anybody in CH digitization. I think we are all need to be reminded just how few people are in this world, right? We're talking about several hundred people involved at significantly deep levels of digitization at museums, libraries, and archives, maybe a few thousand if you're broadening the category a little bit. But the point is, it's a fairly small community, and even a little bit of help can go a long way to somebody else. Other questions? Is it possible an updated C1 SDK might have some more hooks for Python? So I can speak to the Capture One SDK that we referenced we are waiting for in order to schedule the next part 5 of this series, and then also the capstone. Capture One is releasing an SDK that is broader, deeper, and more modern than their current SDK. To be clear, their current SDK is pretty useful if what you want to do is take a raw file and convert it to a TIFF or a JPEG with limited number of parameters, which for what it's worth is a lot of use cases and can be used extensively, but they're going to develop an even broader and more modern one. I believe Python is not on their shortlist for immediate deployment, but a command line version that you'd be able to call from Python with relative ease and get results from is already in the current SDK, and I'm very sure will be part of the updated SDK. So you'd be able to use the new Capture One SDK or the current SDK from Python immediately. And that is, imagine you have 10,000 folders containing 100 raw files from an IQ4 150 megapixel digital back or an IXH 150 megapixel, and you want to crop each of them to be 50 pixels wider than the crop in the raw file metadata. That's something you can do with the SDK today across all of those folders, push the button once, and it basically goes in and processes out all those JPEGs and TIFFs. That sort of thing is really only possible by using the SDK in any sort of efficient way. Thank you, Kurt. We will pause for just a little bit more questions. Do you know if the new SDK will be available in C1 Pro, or is it just for CH and or Enterprise? It's a great question. The SDK is separate from licensing for the software. So it's not that it would be for C1 Pro or for C1CH. It would be that it's the Capture One SDK, the one, and it may or may not have all the features from all the various versions, at least initially. When you release a brand new SDK from the ground up, which is what they're doing, they will target the features they think will be most broadly used. If you, for example, would very much like to use a specific attribute or feature of Capture One via SDK, I would encourage you to reach out to us by email. You can email me in this specific case, dep@digitaltransitions.com, and we will let them know that that is a high priority for you. If it's a high priority for many people and it's reasonably efficacious or reasonably easy to get done, that will be done in the first version. If not, it would be later versions of the SDK. And again, oh, there we go. Is MacBook required for the capstone course, or can you use a Windows machine? So we will give the normal caveat that both Jeremy and myself and our third potential likely instructor are all Mac heavy. That does not mean you can't use Windows. It does mean that our capacity to help you troubleshoot an especially specific or niche problem will be reduced if it is Windows. It will be greater if it's Mac, but we would encourage participants from any walk of life and any kind of computer. Thank you for the question, Alwyn. Miss you, buddy. Okay. So I think we'll call it a day. You can follow up with either Jeremy or I if you had questions that weren't addressed. We really appreciate your time. We are thinking of everybody in a unusual, I guess we'll leave it at unusual year because we don't want to be too negative. But we are all going through different challenges, and we appreciate you taking time to join our Part 4 class. We will see you in the future.
Thank you all.
Carson, you may end the webinar.